talking about how to do a VIRP chart for a complex circuit. So complex circuits are those circuits which have series parts and parallel parts. And unfortunately, the columns, like the voltage column, current column, and resistance column, don't have like simple rules to follow because it's not completely a series circuit and it's not completely a parallel circuit. The two things that we do have going for us are the equations V equals IR, which still works for a complex circuit. And that works like if you have the 2 out of 3 of these quantities, voltage, current, and resistance, in the same row, you can always find the third one by using V equals I times R. Okay, so to find some of these numbers, we're going to actually have to look at the circuit and see what's going on. So the electricity, the current is going to flow out of the battery. It's going to go through the first resistor, right? And because there's nothing in between the first resistor and the battery except for wire, then there's not going to be any change in the circuit. I mean, any change in the current, right? There's no place for some current to go one way and some current go the other. All the current that leaves the battery is going to go through this light bulb or this resistor. Right, it's not until you get to this point where some of the current is going to go down here, some of the current is going to go to the right and down through the third resistor. At that point, the current will split up. But the current that you have at the battery is going to be the same current that you have at the first resistor. That's going to be important as we go on. So the first step will be to add together the resistors. Now, there's 3 resistors, and they're not all series or parallel, so there's not going to be one equation to use for all of them. What we're going to do instead is we're going to add resistors 2 and 3. Each one of those, if you look down here, is 4 ohms each. And these have to be added together in parallel, I'm sorry. And so that's where you do 1 over 4 plus 1 over 4 equals 1 over RT. Right, so 1 over 4 plus 1 over 4 is 2 over 4. If you flip that around, you get 4 over 2, which is the same as 2 ohms. So basically, if we add these 2 resistors together, we get 2 ohms. But then you'd have to add 2 ohms to this one, and this one is in series, so we add them together normally. Then you get 2 plus 3 is 5. So there's a total of 5 ohms of resistance. So now that we know that number, there's another number we can find here, and that's the total current. Voltage is 15, resistance is 5. So we're going to take the equation V equals I times R. So 15 equals this number times 5. Okay, so that number must be 3. Right, because 3 times 5 equals 15. So now we're kind of stuck because remember, this is not a parallel circuit where you could have all 15s going up here. The voltages will not be the same. And it's not a series circuit where you can make the currents all the same either. So we don't know what these are yet. So we're going to have to look at the circuit and see what's happening. At the battery is going to have 15 volts. The current, if you just imagine the current flowing clockwise around here, it's going to go through this this resistor right here. Okay, but notice that all the current that leaves the battery has to go through this resistor. There's no way for it to split up before it gets to the resistor. So that means the current through resistor 1 is also 3. Okay, and we can stop there because we have current and resistance. We want to multiply those together to get voltage. 3 times 3 is 9. Okay, so now they're starting to fill in. But let's think about what's happening to voltage. 15 volts at the battery. You lose 9 at resistor 1. That's what these volts mean. These are how much voltage gets lost when the current goes through the resistor. So you start with 15, lose 9. How much is left? 6, right? And so you have 6 volts left here, right? And these 2 resistors are in parallel. And what happens in parallel is that the two resistors don't split up the voltage. They each get the full voltage. So R2 has 6 volts and R3 also has 6 volts. Okay, so now it's time to use the two equations to figure out the rest of these numbers. V equals I times R, 6 equals some number times 4, and that would be 1.5. Okay, the same problem on row 3, 1.5 again. And now the only only blanks we have left is the power. Okay, so 9 times 3 is 27. Oops, 27. Okay, 6 times 1.5 is 9. Then 6 times 1.5 is 9 again. And 15 times 3 is 45. Right, and if you want to check your work, power is the only quantity that acts normal in acts in a simple way in a complex circuit. So if you add together the individual powers, you do get the total power. So let's add these. 27 times 9 is 36, and then 36 plus 9 is 45, right, which is what we have for total. So if that works out, that's a way to check your work. And if that works out, usually you're going to be right about the rest of the circuit, 98% of the time. Okay, let's look at another one real fast in case you're still confused. And hold on, let me see if any of these are different. Looks like they're all the same. Okay, so we'll just do the last one then. Okay, so you need to add together these resistors in parallel, and these are 2 and 3. So 1/3 plus 1/6, but you need to make the 1/3 into a fraction with 6 in the bottom. So that would be 2/6 plus 1/6 would be 3/6. Flip that over, and you get 6/3, which is another way of saying 2. So we put the 2 right there for the total resistance. Oh, wait a minute, not yet. These two put together are 2 ohms, right? But the total resistance would also include the first resistor. So 6 ohms of resistance here, 2 ohms of resistance here, that would be 8. So actually 8 is the answer. All right, then V equals IR, 16 equals some number times 8. So that'd be 2. And once again, the current that comes out of the battery, and that's what total current talks about. The current that comes out of the battery will all go through R1. So you also have 2 amps of current going through resistor 1. Then we can multiply these together. You get 12. Right? And then let's look at what is happening to the voltage, because that's going to let us know what the voltages of the other resistors are. So you have a 16-volt battery. You lose 12 volts right here. That means there's 4 volts left, right? The 4 volts are each going to go over these resistors, because the resistors don't share the voltage. They both get the whole thing. So both of these resistors are 4 volts each. Okay. So current times resistance equals voltage. So something times 3 is equal to 4, right? And that would be 4/3. And then 4 equals something times 6, 4/6. And then you just multiply these together to get the power over here. So 12 times 2 is 24. Right, 4 times 4/3, when you multiply fractions, you just multiply this number times the top. If you have a whole number in a fraction, you multiply this number times the top, 16/3. So yeah, right there. 4 times 4 over 6 would be 16 over 6. But 16 over 6 can reduce to 8 over 3. So just some fraction math there. And then 16 times 2 is 36. It was 32. 32, I'm sorry. And if you wanted to use a calculator to verify that all these numbers add up to 32, you could, but I can see that these two numbers are going to add up to 24 over 3, which is 8. 8 plus 24 is 32, so that's going to work. Okay, so that is an example, a couple of examples of how to do a complex verb chart.